Now starting. All attendees are in listen-only mode.
Okay, everyone. It is a couple minutes after 12, so we will get started now. My name is Anna Zylik. I'm with ICF, and we are the vendor working on behalf of Eversource and Energize Connecticut to bring these Passive House trainings to all of you. So thanks for joining us today for this Passive House webinar. We are recording this training and we will make this available afterwards. These trainings are at no cost, thanks to Eversource, a proud sponsor of Energize Connecticut. And these trainings are also in partnership with Connecticut Passive House. A reminder that this webinar is eligible for AIA CEUs, specifically one AIA LU, and we will send out a survey and a follow-up email asking a couple questions for anyone who wants to receive the AIA CEUs. Don't forget, we are also offering a 50% cost reimbursement for professionals pursuing either FIAS or FEE accreditation trainings. So that includes the cost of the trainings and the exam. And once you become certified, we'll work with you to process the 50% cost reimbursement. So our email address is down below here on the slide. Feel free to reach out if you do have any questions. With that, I will pass it off to Mark, who's also with ICF, to talk about the Passive House building incentives.
Thanks, Anna. Yeah, John, feel free to jump to the next slide. And yeah, thanks to everyone for joining today. Glad you could all take time out of your busy schedules to hang with us, and excited to have John Loescher here to present. So just real briefly, we like to just provide these reminders at the kickoff of these. So as you may know, Eversource did recently announce Passive House incentives for multifamily buildings with 5 units or more in Connecticut. So if you go to the next slide, this will just show the incentives available for projects. So definitely something to be made aware of. There's some contact information here on the slide as well. You can also reach out to us as well. If you do have any particular questions, make sure we can get you in the hands of the right folks. But as you can see, we have pre-construction incentives with feasibility studies, modeling, and then also certification incentives. So definitely look to take advantage of this. Hopefully this can help your project teams and really achieve Passive House, help with some of the incremental costs to do that. So yeah, just a quick update there to share, and we'll hand it over to John. And thanks again for joining us. Anna and I will be on the line. We'll be monitoring questions, and we'll have some time at the end for questions as well. So thanks again, and yeah, John, over to you.
All right, cool. Thank you so much, Mark and Anna. I appreciate it. It's always nice to talk about Passive House. It's definitely one of my passions. So I am John Loescher. I am a CPHC trainer with FIAS. I'm also the Northeast representative for the Passive House Alliance US. So that's the national organization that supports FIAS. So if you guys have any questions, outside of what we're going to discuss today, feel free to reach out to me. jloescher@fias.org is my email. And then I'm also a Passive House consultant. So I own and operate Northeast Projects LLC, which is primarily a Passive House consulting firm specializing in WUFI modeling. So hopefully we can share a little bit of that expertise today. And today we'll be talking about Passive House 101. So specifically, what is Passive House? Of course, we're gonna cover that. But then also, what is the path to certification? So we're gonna be really diving in a little bit more from the very beginning of the process, trying to define some of these terms that we're gonna be talking about, and then taking kind of step by step through the process to get that plaque and the incentives from Connecticut. So first, what is FIAS? FIAS is the U.S. Passive House certification body. The FIAS mission is to address the climate crisis through passive buildings that can both mitigate and adapt to climate change. As a society overall, we must get to 100% renewable energy. And passive house design is a strategy that focuses on conservation first. And it represents the best way to cost optimize buildings to get to zero. So essentially what we're looking at, our main goal is getting ourselves to 100% renewable energy so that we can address our climate crisis goals. And then we see Passive House as the main tool to get there, right? So Passive House focuses on conservation, so we actually reduce the amount of energy we need in our buildings to begin with. And then the FIAS vision is to make high performance passive building commonplace. So we see a lot of action of passive building in the Northeast, New York, Massachusetts, Connecticut, and we want to keep spreading that all throughout the country. So here is a brief view of all of the different certified projects, about 820 projects certified throughout North America at this point. And we are, as far as energy consumption, doing about 20 to 50% better than DOE's Zero Energy Home program. So if you guys are familiar with that, that is a program that essentially incentivizes renewable energy within our new and existing building retrofits. And Passive House has kind of taken that conservation concept and really put that at the forefront. And because of that, it's being widely adopted throughout the country. So if we look at the kind of progress of FIAS certification, we can see back in 2012, that's when the climate-specific FIAS certification methodology was released to the public, and we can see, you know, maybe just a small amount of projects in the very beginning. The graph we're looking at here is in square feet of building. So, you know, we really started to take off in about 2018. 2019 was a very strong year. Like many things, took a little hit in 2020 with a slight pause, but we're projecting going forward into 2021, almost doubling the amount of square footage that we were able to build in 2019. And a lot of that is due to incentive programs like what is rolling out in Connecticut right at the moment. Okay, so we're going to kind of go step by step here now. First, looking at what's a passive building. I can say if there are questions as we go, please do put them in the chat. If I can get to them, you know, at a good stopping point, I'll take them in between, but otherwise there will be time for questions at the very end of the presentation. So what is a passive building exactly? So the best analogy we can really start to talk about here is a liquid holding device, right? So we have these kind of red plastic solo cup on the left, and then an insulated thermos mug on the right. And this is something that likely all of you guys have had experience with. We could imagine putting a warm drink into the solo cup, and we're holding it in our hand, and all of the heat or cool, the coldness, whatever, you know, would be kind of permeating its way through the plastic, right? We have no insulation value in that. So all of the energy that we put into, say, making the ice or boiling the water, we're slowly over time losing that to the ambient temperature outside of the beverage. Now, if we put it into a thermos, that thermos is insulated, right? So that's going to help minimize the heat loss through the walls of this device. But then we also have a lid, right? And that's air sealed. So we kind of close the lid and lock that in. And that also contributes a huge amount to keeping the heat or the coldness inside of that particular thermos. So we're taking this concept and then we're applying that to our buildings. So essentially the red solo cup is conventional buildings. Granted, building energy code is getting better and better, but that's kind of legally the worst building that we can build is energy code. That's kind of the way that I think about it, right? And then obviously we have passive house on the right. So we're really taking increased measures to keep that heat inside the building, understanding how precious the energy that we're putting into that building to heat it actually is. Okay, so a couple key passive building principles. Starting on the left, we have thermal control, right? So this is, again, a direct analogy with that thermos. We have continuous insulation all the way around the building. That includes the windows, right? So obviously, I think we can all understand you can add insulation to our walls, our roof, our slab, but we can also upgrade the energy performance of our windows. So actually tracing that entire section perimeter of the building and making sure we have continuous insulation all the way around that building is really key. Next, we have radiation control. So when we orient our buildings properly, or even in a retrofit where we don't have much say over how we orient our building, we do get solar heat gain on our buildings, right? So that's free heat. And when we can tune our buildings properly to take advantage of that free heat in the winter when we want it, and then block that free in the summer when we don't want it, that will help us control the amount of heat that's making its way into the building from the sun and outside conditions. But it also helps us reduce our mechanical sizes, right? So the more free heat we can get from the sun in the winter, the less heat we need to supply into the building through our mechanical systems. Moving over from that, we have air control. So the first step would be creating an airtight box. So we use air control layers continuously around the section of our building, including the slab, including the roof, including the walls. And that will help make the air tightness in our building essentially a fraction of what we would see in a conventionally built building. So we perform a blower door test at the end of the construction and determine that we're actually meeting our airtight goals. And that is a criteria for certifying through FIAS. The second part of that air control concept is that we have balanced ventilation with heat recovery. So if we have an airtight box, we eliminate fresh air infiltration from the outside of our building. So in a conventional building, we get that fresh air from the outside in a very uncontrolled way, right? So in the winter, you might put your hand near an outlet cover and you can just feel that cold air coming in through that outlet cover, right? So that's uncontrolled air infiltration. What we're doing with passive building is we're actually using an HRV, a heat recovery ventilator. Installing that in, it takes fresh air from the inside, from the outside, and then delivers that throughout our building and pre-treats that air along the way. And that's the heat recovery portion. So essentially, I won't go through the whole process, it's a little technical, but we bring that cold air into the building, it pre-treats it so that it's not the same temperature as the outside air and delivers that fresh air into the building. This helps bring fresh air in, exhaust stale air out through our bathrooms and our kitchens, and then also make sure that we're bringing that air in a pre-treated way so we don't have to add so much heat or cooling through our mechanical systems. And then all of these aspects essentially result in a minimized mechanical system. So if we go back to like the very beginning of the passive house concept, it was all about this concept of what is the smallest heating and cooling system that we can put into our building. And rather than starting kind of the way that we build now is we build our building envelope and then we determine how big our mechanical system needs to be. Rather, we're going to say what's the smallest system we can be, and then let's actually engineer our building envelope to work with that small system. So we do a building energy balance calculation, and this is the best way to understand what that calculation is. This is something we can either do shorthand, we could do it through PHPP, the planning house, passive house planning package, or through an energy model called WUFI. So WUFI is the backbone for FIAS certification, and essentially what it does is it's an energy model that looks at the whole building, and it looks at our loss buckets, as we call them, on one side, and then our gain buckets on the other side. So on our loss buckets, we have transmission loss, so how do we lose heat through our building envelope? And then how do we lose heat through our ventilation systems, right? So we need to get stale air out of our homes, and then therefore we have to bring fresh air in as well. And there's a huge amount of heat loss that's associated with that. So those are our two heat loss buckets. And then on the other side, we have two gain buckets, or I like to call these free heat, right? So we have our solar heat gains, which we already addressed a bit. And then we have our internal heat gains. So depending on what we're doing in the building, our bodies and metabolic processes are actually giving off heat in our building. So what Passive House can actually do is harness that free heat from the sun, free heat from our bodies, free heat from our computers, our lights, everything that produces heat inside of our building, and actually use that to heat our building rather than our mechanical systems. So the Passive House methodology, as I said, is about calculating our energy losses in order to determine how much heat we have to add back into our building, or cooling. I tend to talk about heat a little bit more because we're in the Northeast, we're in a heating dominated climate, but the same methodology can apply to Arizona, Texas, etc., like more cooling dominated climates. So the key portion of how we determine these targets is not just about that energy conservation. That's obviously a key part, but you can imagine if you've worked on a high performance project like this before, there's really no limit as far as how much insulation you can add, or how tight you can make your building, right? You can kind of keep going and going and going. But what FIAS is trying to do, using a piece of software by NREL called BOPT, is actually find the sweet spot for investment in energy savings. So not only are we focusing on conservation, but we're focusing on conservation in a cost optimized manner, right? So if we look at this chart on the top, this is a screenshot from BOPT. We can see at the bottom along the x-axis, what is our source energy savings? So how much energy are we saving throughout the year? And then we have energy related costs, essentially dollars per year, right? So we can start out here with our kind of conventional build on the left side. I hope you guys can see my mouse. And we can see as we add our conservation methods, we start to actually bring down the total amount of energy related costs throughout the year. So we come to this sweet spot at about 43–44% source energy savings throughout the year, and that's what's considered our cost optimized, right? Once we go past that percentage, then we're actually starting to spend a little bit more money on energy costs throughout the year, and actually spending a little bit too much money on our conservation methods. So this is for one sample project, but this is kind of the base methodology that we apply to all of our certified buildings. Okay, so why do we build to the standard? Like, what is the motivation to do that? I think some of these concepts are already becoming pretty evident based on how I'm speaking about it and what the goal of FIAS is, but I think we can actually break this down a little bit more detailed. So as we can see, we have FIAS Plus certification and FIAS Plus Source Zero certification on the right side of this table. So we have these kind of stepped staircase. leading up from our code building on the very left. So you can see IECC, International Energy Conservation Code 2009 and 2012 as our kind of baseline. Like I mentioned, that's literally the worst building that we can legally build. Then we have a step up from that is Energy Star. So hopefully you guys are somewhat familiar with Energy Star, the Energy Star program. We have Energy Star version 3.1, which is just a little bit better, Zero Energy Ready Homes certification, and then we have FIAS, right? So if you notice the this kind of stair diagram shows that FIAS certification is not only a standalone certification, but it actually includes all of these quality assurance methods that are included in our code-built homes, our Energy Star homes, our Zero Energy Ready homes, and then you'll notice there's also a couple other things that are kind of buried within here. So we have our EPA water sense criteria, so that controls and makes sure that we're providing the most efficient, energy efficient water distribution system within our buildings. And we also have the EPA Indoor Air Plus. So Indoor Air Plus program provides the highest quality of air within our buildings. So we can see over here, the FIAS Plus, the core certification with FIAS includes all of these things. We have a great HERS rating of about 35 to 45 on average if you're only meeting the kind of basic criteria. And then from there, we can go a step further. When you add renewables to a passive house project, it's very, very easy to get to a HERS score of 0, okay? That means we're not whatever we're actually consuming within our building, as far as the source energy, that includes all of the energy consumption from the very production of our energy to what we're actually using in our building, okay? It's a little bit different than net zero, which only accounts for the energy use on site. FIAS plus Source Zero is a really special program. It accounts for all distribution losses throughout, from the very source of that energy production down to actually flipping on that light switch in your building. So we have true net zero buildings when you get the FIAS plus Source Zero certification. Okay, so as I mentioned earlier, we see Passive House as the first step to net zero buildings. So Passive House provides a proven methodology for designing a net zero energy building. The first step is conservation. So through passive measures, we reduce the amount of energy that our buildings are consuming. Then from there, we can add our renewable energy on top of that. So we have protocols for both on-site renewables as well as off-site renewables to offset any additional remaining energy use that we haven't already addressed through conservation methods. So with these reduced loads, there's less renewable energy is needed, and therefore less grid support is needed when the building isn't powered by renewable energy production. Okay, so the current kind of solution for our climate change goals is renewable energy. Like any major leader in climate change is looking towards specifically photovoltaics to address our climate change goals. But the amount of square footage that we need in order to meet those climate change goals is extraordinary, right? So we need to make sure that we're using conservation methods in our buildings, which constitute about 40% of our total energy consumption as a country. So if we can take that 40% of energy consumption and then greatly reduce that through conservation, then we can actually reduce the amount of square footage that's needed for renewable energy. Okay, so getting to zero with a passive building baseline. We first, at the bottom of that, the core of this getting to zero track is the quality, the health, and the durability of our buildings, right? So we don't talk about this enough. We have, when we're making passive house buildings, we're making them high quality, the healthiest air quality possible, and they're durable. Then we add our passive conservation strategies. Then on top of that, we add our active conservation strategies. And that's how we meet FIAS Core, right? So the core FIAS program. From there, we can add on-site renewable energy. And then if we need, we can also get off-site renewable energy. And this is what's going to get us to FIAS 0 certification. Okay, so how do we actually become, how does a building actually become certified? So we already spoke about essentially the different characteristics of a certified building and why we want to do this. So now what is the process of going through and certifying our buildings? So first we need to talk about the different professionals that will help us to certify our buildings. So we build our project team first and foremost. You guys may be familiar with what's known as a CPHC, a Certified Passive House Consultant. This is the designation that FIAS gives to its trained professionals, and this is a required role for certifying a building. So on the design side, when we're designing our buildings, we have a CPHC involved. They are familiar with the certification process. They can provide that energy model to make sure that we are taking a look at the proper energy balance of our building. And ideally, they're as integrated into the design process as possible, so we can really achieve those cost-optimized targets. That CPHC will complete the energy model and then assures the project meets all requirements during the design phase. So that is kind of the core of the CPHC, or the certification process. Now, I'm going to skip over to the right first, because the other required role is in the verification side of things. So we have two project team members here, or two designations. One is a FIAS Plus rater, the other is a FIAS Plus verifier. So the difference is the FIAS Plus rater is trained in smaller buildings, so 5 stories and below. A FIAS Plus verifier, because you can imagine when you get up to a much larger building typology, things are going to change a little bit. So a FIAS Plus verifier is essentially an add-on certification to the FIAS rater. And the FIAS verifier is going to be a specialist in verifying much larger buildings, especially as we're getting into multifamily and more tower typologies. So ideally, this rater would come in or be somewhat peripherally involved in the design process, just to make everyone aware of what their role is. But where they really come in is as the building is going under construction. They are the ones that are on site. A pre-qualification to be a FIAS rater is to be a HERS rater, so they're already trained in on-site verification. They come in at multiple stages throughout the construction and verify that the building is being completed or constructed as it was designed. Now, right in the center here, we have a certified builder. Now, within the past couple of years, the FIAS builder certification has really skyrocketed. There's a lot of professionals out there now that are becoming FIAS certified builders, because there's a lot of minor details that you need to know as you're constructing the building. So this is not required, though it's highly recommended. You can build a passive house without a FIAS certified builder. However, maybe some on-site training would at least be recommended if they're not already a certified builder. They will be responsible for maintaining the quality and oversight during construction, and essentially make the FIAS rater's life a lot easier. They also help ensure that the air tightness target is met. So when we're talking about air tightness, we're talking about really scrutinizing every single detail as we go through the building, because each of those little details is an opportunity for air infiltration through the building envelope. Knowing that the FIAS rater won't be on site every single day, it helps to have someone that's responsible on site that is actually looking at these things in a more nuanced basis. Okay, so as I said, there's two parts to FIAS certification. First, we have the pre-certification, which is the role of the CPHC. The CPHC will submit that work to FIAS, and FIAS will check all of that work. So as a CPHC, I'm really grateful for this process, right? Because we're dealing with a lot of really nuanced pieces of information, and it's very great to have an extra eye on the design process just to make sure that we're hitting all the criteria. It's reviewed by FIAS, and then there's a slight back and forth after the review where we have comments that go back and forth and essentially just clarify all of the design elements. And then we have final certification. So we go through the design process, we speak with FIAS, we get pre-certified, right? So when the building is pre-certified, we're essentially cleared to build that building. And as long as we build exactly to the drawings and the specifications, final certification should be no problem. So final certification is largely made up of on-site quality assurance and testing. So we have an inspection completed by the FIAS rater, who is a third party. They are isolated from the CPHC ideally so that there's no conflict of interest here. Okay, they will review all the documents completed by FIAS and the CPHC, and then they'll true up that final energy model to match the as-built, right? So one good example is in the design process for pre-certification, we're using the FIAS air tightness limit, which is 0.06 CFM per square foot. Now that's just a target that we want to hit. Now for final certification, it's very likely that you're going to exceed that air tightness. So we actually go through, the FIAS rater will go through and identify where we exceeded our targets. And then we can actually update our energy model at the very end of construction to see what the simulated energy performance of that building will be. Okay. Again, the whole building energy performance is part of the pre-certification. So this is where the backbone is really the WUFI Passive modeling software. So we're seeing that on the bottom left here, where we actually build out our building. We can take a look at the climate. So we import climate data into our building. And then we have, it's kind of hard to see here, but very live updating performance of our particular building. You can also see these 5 green dots here. Those are really nice green check marks. So when we have all those green check marks, we're good to go. We can certify this building. And the basis of the QA/QC, the on-site process for final certification, would be a FIAS Plus quality control workbook, essentially an Excel document that the FIAS Plus rater or verifier will bring on site, and it's checklist based. So we can go on site and just make sure that we're hitting all of those specific targets. So those specific targets, what exactly are they? So first we have space conditioning targets at the very top here. So as we can see in the red dash, these are requirements for all FIAS certifications. Those space conditioning targets can be broken down into what is our annual heating demand and annual cooling demand. So throughout the entire year, how much energy are we going to spend on both heating and on cooling? So those are the first 2 targets. The second 2 space conditioning targets are our peak heating load and peak cooling load. So those speak to the worst case scenario, right? So January, February in Massachusetts, Connecticut, New York, we have the coldest peak temperatures of the year. Are we going to have enough capacity within our mechanical systems to meet those peak targets? And then the last part of that is the quality assurance and on-site testing, which I already spoke about quite a bit, as well as the air tightness, which the target would be 0.06 CFM per square foot. Now, outside of this red dash box is our net source energy target. So for FIAS Core certification, we have a per person fair share source energy target of about 3,600 kilowatt hours per person per year. So that's based on all of the people on the planet and the amount of energy we would consume if we were to hit that 1.5 degrees Celsius of global warming target. So we have an allowance, essentially how much carbon we can put into the atmosphere within safe methods, and then we take that allowance and we divide that by all of the people on the planet, right? So that's a fair share energy use target. And that is what's required in the FIAS Core certification. Like I said earlier, we can also go above and beyond that to FIAS Source Zero target. So the difference between a FIAS Core project and a FIAS Source Zero project is going to be that that core project is meeting the fair share principle of 3,600 kilowatt hours per person per year. And then the Source Zero project is going to be 0 kilowatt hours per person per year. On top of that, we do have some other requirements that are just helping to address the overall durability, comfort, and health of our buildings. So what we're seeing on the left here is a comfort assessment and condensation risk calculator that we can use. Essentially, it ensures that we do not have condensation on any of our building assemblies or windows. And then it also ensures that if we have, say, a large pane of glass, and we actually go up to that pane of glass in the middle of January, in the middle of February, and we put our hand up to it, that pane of glass is only going to be, it must be within 7 degrees Fahrenheit of the interior temperature. That's how we've decided or determined what would be comfortable within the building. So again, if we talk about a conventional building, you have a window seat built in a conventional building. In the middle of winter, you're not going to want to sit in that window seat, right? That window seat's going to be cold and uncomfortable, and you're going to have very cold temperatures on the surface of that glass. Not with a FIAS building. With a passive house, we can build that window seat, and in the middle, the coldest day of the year, the coldest hour of that day, we can sit at that window seat and have our back up against the glass and still be very, very comfortable. The other part of this that's built into the FIAS certification would be moisture control guidelines. So this is really dealing with the durability of our buildings. So there are climate-specific moisture control guidelines that we must adhere to in order to certify our buildings. And that assures that when the relative humidity and temperature fluctuates throughout the year, we're never going to get condensation forming within our walls. Condensation forming within our walls can lead to mold growth, it can lead to wood rot, and lead to lower R values in our insulation. So we can do all this work to super insulate and airtight our buildings, but if we get condensation, all of that work is for nothing, right? Our buildings are going to fall apart if we don't address that moisture control guidelines. Okay. You know what? I'm going to skip this just to keep moving here. So what I had just spoken to was the typical path for FIAS certification. Now that's going to apply to single-family homes, multifamily homes, and non-residential projects. But with 2021, FIAS has just announced a new alternate approach for FIAS Core projects, and that would be the FIAS Core prescriptive path. So essentially for small projects, single family, detached or attached residences, we have very specific criteria, And admittedly, they're a little bit more conservative than the performance path, what we kind of already addressed. But essentially, we have a checklist of things that we need to meet. And with the prescriptive path, the idea and the goal is that we've been doing this since 2012, outside, basically since FIAS kind of separated from the German PHI standard. And we've really refined that system very well for single-family residential projects. So we've been able to quantify and create the prescriptive path. If you can meet all of these prescribed requirements for your single-family building, you can certify your building without an energy model and in just a fraction of the amount of time, right? So this applies to, like I said, single-family detached or attached residences, homes where the floor area to bedroom ratio is less than 900 square feet per person. So there's a certain density of building. We cannot have any fossil fuel combustion equipment within our airtight box, which is strongly, strongly recommended for any project. And then there's some other limitations, like unfortunately no jetted tubs or indoor pools because of humidity concerns, and no natural draft fireplaces. The FIAS prescriptive path is all available on fias.org if you'd like to check that out a little bit more. But the biggest benefit, especially if you guys are interested in becoming CPHCs, is that you can now certify these smaller projects without WUFI energy modeling. So if you're looking at a single family home, excuse me, you can either use WUFI passive modeling or the prescriptive path in order to certify your projects. If for some reason the FIAS modeling, the prescriptive path does not work out, or your building cannot meet all those requirements, you can then simply go back to the performance path and do the energy model. The energy model gives you a little bit more flexibility to kind of balance things out. You can have lower performing windows by adding more insulation to your wall, etc. Right? So it's all about that building energy balance calculation. And within both of these programs is this DOE high performance staircase, like I had explained earlier. Okay. All right, I don't see anything in the chat yet. I'm going to just keep trying wrapping up. We have just a few more slides and then we can take questions. So now that you're a bit more familiar with what a passive house is, the elements, and then how you become certified, just taking a look briefly at some common design features that you can find within a certified passive house. We have continuous insulation, like we spoke about, that minimizes our losses and gains. We have structural thermal breaks. So especially when we get into larger projects, like what we're seeing here, this is Studio Gang in Chicago, the Aqua Tower. It's not Studio Gang's fault. This was value engineered out of the project in the construction process. But if you look at the infrared images of this project, we have continuous concrete slabs that make their way inside and outside of the glass facade of the building. They were originally designed with structural thermal breaks, isolating the inside from the outside. This was value engineered out of the project. And as we can see in this diagram in the bottom center here, heat will then just leak its way out through the building, through those concrete slabs, through the winter. And then we also lose our cooling throughout the summer. So this is kind of a subcategory within that continuous insulation to make sure we're keeping the heat in our buildings. Next, we would look at thermally broken fasteners. So when we're attaching things to the outside of our building, how do we use clip systems and different inert materials to actually connect those things and again reduce the thermal bridging that we have within our building envelope. By eliminating these thermal bridges, we also eliminate that condensation risk, because as we have these thermal bridges, the inside surfaces of our building, as we can see in the center here, become cooler. And when they become cooler, they come closer to their dew point temperature. When you get to your dew point temperature, we get condensation. And as I said before, that leads to mold growth and other deterioration of our building. We have our airtight barrier or airtight construction. So this can occur at different junctions within our building. As we're seeing here, this is a spray-on application being done for a larger building. We have a continuous balanced ventilation heat recovery. Like I said before, essentially we'll bring in fresh air, precondition that air, and deliver that to all of our living spaces. We have that balanced ventilation, so we're supplying fresh air to our bedrooms, our living spaces, our kitchens, etc. And then we're exhausting all of that stale air from our kitchens, our bathrooms, our mechanical rooms, our laundry rooms, etc. So wherever we get particles, particulates in the air that we want to remove, especially when we're cooking, I can't stress that enough. We need to get those out of our building as soon as possible and replace that with preconditioned fresh air. And then lastly, we have our minimized efficient mechanical systems. So we have efficient lighting. So ideally 100% high efficiency lighting. Usually that means LED lighting. We have devices such as heat pump hot water heaters, which can act basically 300 to 5% more efficient than an electric resistance heater, which is about 100% efficient. And then we have mini split heat pumps, which are also 300 to 500% efficient when compared to combustion systems, which are about 75 to 80% efficient. When I'm talking efficiency, I'm talking energy in versus energy out. Heat pumps are definitely the way of the future, definitely the way to minimize our energy loss, because we can put in 1 unit of energy and get out 5 units of energy. Okay, so lastly, I know I've been kind of talking quick and threw a lot out to you guys. I just want to make a couple additional resources available. So we have the FIAS Plus certification guidebook. This is free online if you go to fias.org. This is a 160-ish page document that will actually outline the entire certification process for you with detail about pretty much every single item. For other resources, we have the Passive Building Design Guide for multifamily construction. This is a great resource for developers, investors, and other construction professionals. We have a policy roadmap to clean carbon construction. This is for governments, not-for-profits, and other public policy professionals. And then we have the Passive Building Design Guide, which is for commercial construction. So the base of FIAS certification has been single family for many, many years now. As you guys probably have noticed, multifamily over the past couple of years has really grown exponentially. And then the next frontier is commercial construction here. And then lastly, to become a FIAS professional, this is where you need to take advantage of these incentives from Connecticut. Go to fias.org/become a professional. We run online trainings. I'm teaching one this week. Today's my day off. Tomorrow I'm going to start teaching WUFI Passive to a group of about 20. We run them almost every month for the CPHC because there's a very high demand. We're currently running multiple certified builder courses as well, also online, and a FIAS Plus Rater and Verifier training, which again can all be found at fias.org. Lastly, I just have to plug FIAS Alliance. I am on the board of FIAS Alliance and I'm your Northeast representative. You can always reach out to me with any questions about how to get more involved within our greater network. And hopefully we will see you guys our FIESCon, the 2021 conference, is being scheduled for in-person in Tarrytown, New York. This is FIES Alliance's big event throughout the year, and it's an amazing opportunity to see what's going on in the area. It travels all throughout the country through different parts of the year, so it's a real treat that we have it in New York this year. Fingers crossed that we can actually pull it off in person, but there will be an alternative plan for online remote conference if we cannot do in person. So keep an eye out for that. You can go to fies.org/alliance/join support, join the alliance if you would like to be a part. I know that's a mouthful. Just Google FIES Alliance and you'll find it very easily. Okay, so I will stop talking now. Thank you so much. Again, my name is John Loescher. I think we have a few minutes left and hopefully we can take some questions.
Yeah, John, great job. Thanks for getting through all that. And we do have a few questions. I can rattle them off for you, John, if you want to
Sure.
to respond. So one question was around load calculations. And will load calculations come into play when determining peak cooling and heating demand targets?
Yeah, great question. So when we're certifying our buildings, we're talking about the whole building energy consumption. So when we go through our WUFI energy model, our peak heating and peak cooling, those are essentially our load targets. So we determine what those loads are, and then we can essentially kind of roughly size our mechanical systems based off of that. I will kind of put one note that because it's a whole building energy analysis, it's for the whole building. So I would always still recommend having a mechanical engineer, because the mechanical engineer can do your manual J and a room by room distribution to make sure that the heating and cooling is distributed properly. That is one thing that WUFI does not really address within the software.
Great. A question around windows: is triple glazing and or like a minimum U value required?
So we do have recommended U values. Now, because we are doing a whole building energy balance calculation, you can actually do some trade-offs. So you could do lower performing windows. You're just going to have to make up for that energy consumption somewhere else by a better air tightness or more insulation, something like that. Now, that also touches on the difference between the building. So small projects, single family homes, tend to be heating dominated, especially in our climate. Usually we're going to see triple glazed high performance windows in our single family homes because we have less heat being generated in our buildings. Now, when we get to larger buildings like multifamily, it is possible to go from triple glaze to dual glaze because you have a lot more people in the building generating heat. So we tend to kind of shift away from an extremely heating dominated project to a little bit closer to a cooling dominated project. So the building physics essentially shift a little bit when you shift in scale of project.
Great. A question around the FIES prescriptive path. Do you know if there's any homes, I'm assuming this is no, just since it was recently rolled out this year, but one question was around any homes that are available to visit or tour in Mass or Connecticut that went through prescriptive. I'm guessing no at this point.
Yeah, so no projects have actually been certified through the prescriptive path yet. I think there will be a lot if you give it a year, but right now we're seeing, like, I personally have 6 prescriptive path projects that I'm working on right now. That's obviously all in the design phase. So, you know, we need to get through this kind of construction boom, make sure those houses get built, and then those will be certified after. I would imagine most of those projects, or some of them, will be available for tours. I'm located in New York, and we do a lot of tours through our local Passive House Alliance chapter. So if you guys want to check that out, you can go to pha-hv.org and sign up for our mailing list. We do have some projects closer to like Western Mass, Western Connecticut, But as far as other project tours, look for just a regular FIA certified project in the area. Usually the community is great. People want to share this information. So even if there's not a formal tour, you might be able to reach out to the architect, owner, designer, and see if you could set something up.
Great. A couple questions you might be able to hit on quick here, John, is the difference between ERV and HRV, and then just in terms of air filtration of outside air, any like MERV levels, requirements, or suggestions there?
Yeah, great question. So MERV 13 is required. That's one of the highest levels of MERV filtration. That's required within your ERV or HRV. Really, we're kind of, as the passive house industry is kind of moving away from HRVs a little bit and focusing more on ERVs. There's differences in efficiency because HRVs are doing less. So you can get like upwards of 90% efficiency for the heat recovery. ERVs recover both heat and humidity. So they're doing more, so they're a little bit less efficient. But I can say from experience, in New York, I'm in most projects climate zone 5A. It's well worth it to get the ERV. It doesn't dehumidify your air, but it does help just regulate and keep you within the ASHRAE recommended values of 40 to 60% relative humidity.
Great. We got a couple more here. Let's see. There's a question around blower door testing. Is that required? And if so, how often throughout the project?
Yeah. It's only required once. It's only required once for your final blower door test. It's recommended you do more, but it is only required once because we need to verify that you're meeting the air tightness requirement of 0.06 CFM per square foot. Now, the prescriptive path does require 2. So it does require kind of midway point blower door test as well as the final. Now, if you're a builder, I would recommend, purchasing a blower door test because it's a little stressful if you wait until the very end to do your blower door and see what your air tightness is. So there are certain kind of points throughout the construction process that it makes sense to do it. And I usually recommend doing it as much as possible. That's something even I'll do as a CPHC is go out to a job site under construction and do the blower door test just to verify that they're kind of in the right path forward.
Great. Does opting to pursue the FIAS Core Prescriptive 2021 certification present a cost savings for clients just due to the lack of WUFI modeling?
That's really good, and I would say the data is not out on that yet because so for instance, a project that I'm working on, we essentially used a performance path project as like the baseline. So we took all the assemblies and then we applied those assemblies to the new project. And admittedly, we needed a slightly higher R value for some of those assemblies. So like if you look at the extra insulation you had to add, you might be putting the money into that additional insulation rather than into the energy modeling. I do still believe that the biggest benefit of the prescriptive path is time. Like I can do this in probably a quarter of the amount of time that it takes me to do this energy model. So we can actually really increase how rapidly we're certifying projects. I think that is for sure a benefit, but the cost savings are maybe still a little bit out.
Yeah, thanks, John. We'll go through 2 more of these. I know we're getting up against the clock and want to be respectful of everyone's busy schedules today. And there's a couple questions, one blower door related, one balanced ventilation. So multifamily, does that require each unit, or is there compartmentalization or sampling in terms of blower door for multifamily units?
Yeah, great question. So this is really important. This is where the FIAS rater comes in. So FIAS only requires that final blower door test, which would be for the whole building. Because we're certifying the whole building, we're not certifying individual units. However, if you get into multifamily, there are compartmentalization blower door tests that need to be conducted for your other prerequisite programs. I believe the zero energy ready home, and I believe even just building code, compartmentalization. So you do need to do unit blower door tests as well, but the air tightness requirement is way more relaxed than what we're doing for the whole building envelope.
And could you just take a minute, John, to touch on balanced ventilation? Just give maybe a quick definition of that.
Sure. Yeah. The most basic way to describe it would be if you have a 2-room home. One room is a kitchen, the other room is your living room. A balanced ventilation will exhaust, let's say 100 CFM. That's a lot, but just to keep it simple, 100 CFM, it's going to be extracting from the kitchen. So then to become balanced, it's supplying 100 CFM to the living space. So you're in your kitchen, you're cooking, particulates are going into the air, it's removing those particulates, filtering those out throughout the ERV, and then it's bringing that filtered air back in, putting it into your living room where you're kind of hanging out, watching TV, whatever, and then you get kind of surrounded by fresh air. And the key to the balancing is that you're extracting and supplying the same amount. So that actually speaks to the pressure in your building. You want to maintain like an even pressure so you're comfortable. When you start exhausting only, you're actually depressurizing your building. In an airtight box, like you're going to notice like your ears might start popping, or you're just going to be generally uncomfortable. So balanced ventilation is really important.
And final question before some closing remarks is just around VRFs. And this is an interesting one. Any concerns about the amount of refrigerant in VRF systems and its availability due to phasing out of refrigerants currently used?
Yeah, personally, I don't have too much experience with VRFs. FIAS in general kind of does not regulate refrigerants, embodied carbon in materials, things like that. So many projects can be certified with VRFs. I personally don't have that much experience, like I said, but there's no concerns kind of that I'm aware of. I don't know if that totally answers the question, but that's kind of the best I got.
Yeah, that was a good one. Yeah, with that, I want to thank John for taking time out of your day, John, to join us today, and everyone that was able to attend today as well. Really appreciate it. There were a few questions that came in just around some of the FIAS professional accreditations and training opportunities. So definitely check out the FIAS website. They've been great with offering a lot of different virtual training opportunities throughout the year. There's a lot coming up. You can feel free to reach out to us here at ICF as well. The Passive House Training CT email address at the bottom of the screen. We're happy to help direct folks to any of those training opportunities through FIAS or PHI for that matter. And again, we do offer that cost share reimbursement of 50% towards those costs. So once you do the training, take the exam and pass, we're able to help support some of those costs. So yeah, definitely reach out to us. We're happy to help. And we will have future trainings coming up similar to the one today. We kind of focus on these lunch and learn, 1 to 2 hour trainings around this hour, but also looking at some building science workshops. These are typically 4-part workshops that are a little bit more involved in terms of time commitment and get a bit more technical. So, we'll be continuing to offer these throughout the year and into next year. So certainly be on the lookout. Check out the Connecticut Passive House website as well. You can sign up for their newsletter to be up to date on any upcoming trainings. So look out for our survey. We'll also be asking for some information in order to submit any information to get AIA credits, as we mentioned. So we will collect information there. But with that, thanks again, John. Thanks for everyone who attended, and we'll catch you next time.
Beautiful. Thanks for having me.
Have a great day, everybody.